In a mathematical achievement test for 10th standard class, question 1, 2 and 3 are solved by students 60%, 30% and 10% respectively. Find the relative difficulty level of each question. Assume that solving capacity of the students is normally distributed in the universe. So what is given here is question 1 students can solve, question 1 60%, question 2 30% and question 3 10% of the students can only solve. We will see. First we go to question 3. How many students can solve question 3? Only 10% of the students can solve question 3. Okay, we'll write it down. Only 10% students can solve question number 3, which implies 100 minus 10. That is 90% of students cannot solve question number 3. Okay, so 90% of the students cannot solve question 3. That means it is on the right hand side. This is on the right hand side of the normal curve. So if you see the normal curve, okay, only 10% of students can solve question number 3. Okay, this question number 3 can be solved only by question number 3 can be solved only by 10% of the students. Okay, so I can call these students as only these many students can solve question number 3. 90% of the students cannot solve, only these many students can solve question number 3. Okay, I can call these students as most intelligent students. Okay, now now 30% of students can solve question number 2. Okay, 30% of the students can solve question number 2. We'll see question number 2. So if I draw the normal curve, in this 30%, even it includes the most intelligent students. Okay, this 30% includes most intelligent students, that is even 10% also. Okay, so I can say this 10% also included in this 20%, 30%. So this 20%. So this 20% of the students, that is 30. 20 plus 10 is 30. 30% of the students can solve question number 2. Okay, this is my question number 2. So 30% of the students can solve question number 2, and this includes our 10% of the students, that is most intelligent students. So I can call these students as these students. Okay, these students I can call them as so if I take these students I can call them as intelligent students. Okay, 20% of the students is intelligent students. If I include this 10%, this 10% is our most intelligent. This is my most intelligent students. Now you go to the question number 1. How many of them can solve question number 1? 60%. So I can say 60% of students can solve question number 1. Okay, it includes the most intelligent students plus intelligent students. It includes most intelligent and intelligent students also. So 50%. 50% equal to, how I can write 50%? 50% equal to, 60%, sorry, I'm so sorry. 60% equal to 50% plus 60%, 10%. Okay, I can write 60% as 60% is nothing but 50% plus 10%. 50% is right hand side and 10% is left hand side. Okay, so how I can draw the normal curve? So 60% includes our 50% also. 50 plus 10 is 60. So there are some students. Okay, so here I am getting this 20% of the students, that is intelligent students, 10% of the students who are most intelligent, and here 20%, so 20, 20, 40 plus 10, 50, and 10 also we need. So this side is 10%. Okay, so I can say this is my most intelligent. This is my intelligent students and average students. If I talk about the average students, who are all my average students? 10%, that is in the left hand side, 20% in the right hand side. So these students I can call it as average students. Okay, these students I can call it as average students. So we'll see the total curve, how it will be. Okay, here I can say these students can solve here question number 1. Okay, and here the students can solve question number 2, and here question number 3. Okay, from here to the end is 60%. Okay, from here till the end is our 30%. This is, okay, from here till the end is 10%. Okay. So I'll write 30% here. It will be more clear. Okay. So from this point to end, it is 60%. From this point till end, it is 30%. And from this point till end, it is 10%. Okay, I can divide the curve like this. Now I need the points, sigma distance. So I want to know how much far away from the mean. Okay, I can call this as mean. And this is how much far away from the mean. Okay, and this point is how much far away from the mean. Sigma distance. Okay, so I will call this as mean. Okay, what is the distance? Sigma distance. I want to find the sigma distance, and also this sigma distance, and also this sigma distance. In order to find this sigma distance, I have to use the table. Okay, in order to find the sigma distance, I have to use the statistical table. So 20, where the 20 comes, we will be seeing the area. 20 or approximately 20. Okay. 20. This is very close to 20, right? 0. See, 0.52. That is, if you see 0.52, this point, that is 0.1985. 0.1985 is very closer to 2. 0.2019 is a bit far away. This is much closer to 2. So we can take the answer as 0.52. 0.52, right? So closer to 20 is 0.52. This is 0.52 sigma distance. I can call this as 0.52 sigma distance. Now 20 plus 20, 40. What is this? 20 plus 20, 40. So 40 we will see. Where the 40 lies. Okay, where the 40 lies, we'll see the normal curve. 40 is this one. This is 1.28. What is this point? 1.28. So this is 0.3997. 0.3997 is closer to 4. So this is 1.28. I can call this as 1.28 sigma distance. Right? I have to see this 10%. 10%. 10%. 10% will be 0.25. This is closer to 10. Okay, this point is closer to 10. That is